We're reviewing the process to price a put option and a call option. In this case, we've got data for several years of daily data on historical prices for Walmart stock. And the prices are as of the end of the day, August 24th, 2021. We've also got option prices from the market as of beginning of August 25th, 2021. So these are about as close as we can match in terms of what was the current price of the Walmart stock and what were the current option prices on the market. Now, in this case, what we're going to do is use data over 2021 to estimate the volatility of Walmart stock. There's actually 5 years of historical data in this list, but there's some question as to, what volatility matches the future expectations for the options investor. So it seems like 2021 in this case might match better with the forward-looking expectations. So when we calculate the standard deviation and the mean, we're using just 2021 data down to row 163. So in a previous video, an exercise, we calculated the geometric Brownian motion parameters, and that's what's done here. Note that the delta, the time period for the estimate, is 1 over 252 because we're using daily data. These options that we're going to price are expiring on January 21, 2022, which is 149 days from August 25th. So for the simulation, we're going to be using a time period of 149 divided by 365. That's the t, large T is the time to expiration, but in the geometric Brownian motion formula, it'll be the delta for the simulation. Right now, the risk-free rate is very low, about 0.05% for the 6-month Treasury bill, which is an expiration that's not exactly 149 days, but it's relatively close. All right, so we need to simulate our ending stock price. Okay, so we need to simulate the ending stock price on the expiration date for this option. To do that, we're going to need to create a standard normal random variable. And in the geometric Brownian motion formula, the notation is this z. So we'll create that here with an at-risk distribution. And we'll select the normal. You may need to go into the continuous distributions and find normal. But it'll be mean 0, standard deviation 1. Okay, so we've got over here the geometric Brownian motion formula. When we're simulating option prices, then, what we're going to do is simulate this with a risk-free evolution of the stock price. And that's because once we pay the cost of the option is in a sense risk-free. We don't ever have to exercise it as a loss once we consider the cost of it a sunk cost. So we'll simulate this. It'll be the current stock price, which for Walmart is over here, 148.9, times the exponential function. And instead of using the mu hat for the stock, in this case, since we're dealing with options, we're going to use the risk-free rate minus sigma squared divided by 2, and then times the delta for the simulation, which is also the time to expiration for the options, plus sigma, which is the volatility, times the square root of delta for the simulation, times Z. And that should give us the ending stock price that we'll simulate. All right, in this case, we'll price a call option and a put option that have a strike price of 150. And so the call option, I'm going to refer to this as call option payoff. All right, so the call option has a payoff that is the maximum of 0 or the ending stock price minus the strike price. Now we're going to discount this at a continuous rate, and to do that what we would do is use the exponential function with a negative sign here because we're discounting, times delta for the simulation times the risk-free rate. So technically these cash flows for options are discounted at the risk-free rate because they happen in the future. It's a really small discount rate, so it's going to have hardly any effect on this in this case. So for some of the additional analysis, we may actually take this discounting factor out. For the put option, the payoff is the opposite, the strike price, minus the ending stock price. And we'll put in the same discount factor. So we want to make these both outputs in at risk. Call option payoff put option payoff. All right, one thing to note here is right now the market price of these options, got a screen capture of these call option prices and put option prices. Right now, at that time, on the morning of August 25th, this option was trading for 610. That's the call option. And the put option was trading for 150. Strike price of 150 was trading for 795. So it'll be interesting to see how our estimate here with simulation matches these market prices. So we'll go ahead and simulate this. We'll start with 1,000 trials. And what we see here is our simulated mean for the call option is $6.06. Now there's a 90% confidence interval for that mean of about 51 cents. So, you know, there's certainly a range of values where the option price could lie. 50 cents on either side of $6.06. Because this is a fairly wide confidence interval, with options, sometimes we may want to extend the number of trials we use. So it's a small model. I'll use 10,000 trials. So you can see what that does is reduce the confidence interval significantly. Now our estimate of the option price is $6.07, the mean. If we look at the put option, our estimate is $7.14, 7.138. So I'm going to put over here, this is the simulated option price, 6.07, about 7.14. This is very close to the actual price, which seems to indicate that in all likelihood, this volatility is about what's being factored into the call option price. Our simulated price for the put option is a little bit low, and one reason is because Walmart is, there's some volatility in Walmart, and so there may be early exercise availability with the put option. In other words, if before January 21st the price gets low enough, an investor may want to go ahead and exercise it early, and so this early exercise feature has some value. And that may not be captured here because we're treating this as a European option. But because we've got the call option price relatively close, this model should allow us, even though we're not completely capturing the early exercise, it should allow us to do the analysis we want of options as part of other portfolios. So we'll go ahead with that now.